Hi, this is an overview of the CodeHS Computer Science 1 course for Texas. I'm starting on the student side, so this is what the course looks like to a student. You can see that the course is structured of modules, and within modules there are lessons, and within lessons there are individual activities. The structure of our lessons can vary, but here's a typical coding lesson. The lesson starts with an instructional video. This is where students are introduced to the content of the lesson and shown a live coding example. After students are done watching the video, the next activity is a short multiple choice quiz. This quiz serves as a check for understanding to make sure students understand the content of the video at a basic level before they start to apply it in their coding practice. Because this is a formative assessment, students receive feedback and explanations to correct their misunderstandings. Next, students are given an example program that they can run, edit, and explore. In this lesson, students are learning how to generate random numbers. So this JavaScript example shows how students can use the randomizer function to simulate a six-sided die roll. Students can investigate how this program works by making their own edits or additions, and then rerunning the program to see what the impact of their changes are. For example, let's see if I can modify this to make it an eight-sided die. Here we go. And then when they are done with this program, it's time for them to move on from the example and apply what they learned to creating their own coding program. This exercise is asking me to write a program that uses a random number generator to create a random multiplication problem for the user. Let's run the code that I've written so far. So the lowest number I want to multiply, I'll say 2, and the highest number I want to multiply, I'll say 5. And now it's asking 5 times 5, so 25. And this is saying the correct answer is 10. So that's not quite right. Many of our coding exercises have test cases that give students instant feedback as they work through their code. So when I click check code, I'm seeing now that my output isn't printing the correct answer to the multiplication problem. So when I go to the line that prints the correct answer, I can see that I'm actually adding the two numbers instead of multiplying. So when I fix this and I check my code again, I can see that I pass all of the test cases now. Each lesson will have several exercises for students to practice creating their own programs. Now let's take a look on the teacher side. In addition to the student-facing activities, we offer a number of resources to support teachers as they deliver the course content to their students. This is the lesson plan for the student lesson that we just looked at. After a short description and lesson objectives, you can see all of the activities for the given lesson. You'll notice that for the video, teachers also have access to the slides that are used. Teachers have the option to use the slides instead of the video, or they can provide students with a copy of the slides as an additional resource. You can also see that the quiz can be printed by teachers if they want to deliver it as an offline assessment. For each of the exercises, teachers have access to the solution. In addition to the solution, our exercises come with problem guides that offer a more in-depth look at the exercise. You can see here that in addition to the solution, which is shown here, teachers also can look at the motivation. So why are we asking students to complete this exercise? What are we looking for them to practice or understand? As well as a set of common questions. The common questions section identifies some of the common mistakes and misunderstandings you might see from students as they complete the exercise, and it also provides you with an explanation that you can use to correct their misunderstandings. Let's go back to the lesson plan. After problem guides, you can see key vocabulary terms for the lesson, and you can also see planning notes as well as recommended teaching and learning strategies that may help in the delivery of the lesson. We note any prior knowledge that's needed to be successful in the lesson, and we provide video slides. We also provide discussion questions that can be used in the beginning and end of class, and we also recommend modifications for advanced students, special education students, and English language learners. And finally, teachers can see the standards alignments for the given lesson. In addition to the curricular resources, CodeHS offers a suite of tools to help teachers more effectively grade work, track student progress, and deliver high-quality computer science instruction that meets the needs of their students. If you would like more information, please don't hesitate to contact us at hello@codehs.com.